As human beings, we are deeply rooted and connected to our natural environments. Research shows that human health and well-being is impacted in 3 ways: socially, physically, and psychologically, with a vast list of positive effects. This design proposal considers close relationships between natural environments and human well-being in the Kamuzu University Teaching Hospital, focusing largely on the user experience by integrating green spaces and creating pedestrian-friendly pathways that form strong relationships with the surrounding landscape. The campus site is located in Blantyre, Malawi, about 10 miles north of the Chileka Airport, and is divided into 4 quadrants. This proposal for a new bioprocessing facility focuses on the southern tip of the southeast quadrant. Topography suggests a small slope in the landscape towards the northeast region of the site. This will be the main course for water movement and will require on-site water management considerations. The sun remains directly overhead for a large portion of the year, which will require shading methods, but also allows for good solar performance through the use of solar panels. Southern prevailing winds can also be used for passive ventilation throughout buildings. The initial site concept developed from the idea of a flowing system of pathways through scattered green spaces moving north through the site. These flowing pathways went a step further and began to split up and define programmatic elements. The main program is split up into an education and administration and a manufacturing building. The manufacturing building is the most private, and so this is pushed towards the eastern side of the site away from the main road. A separate utility road is provided for product transportation. Directly west of the manufacturing facility is the more public education and administration building. Both facilities share a central courtyard space. Main traffic will arrive and enter at the southern tip, where they will be greeted with a stunning natural vista and travel north to the 2 main parking areas. Covered walkways are incorporated to provide shade and shelter from the elements as visitors approach the main facility. Rainwater is collected and stored in cisterns located near each building, and excess water is sent north to water management. Education and administration spaces are split and accessed by a rain garden corridor. Program on either side is organized around open-air courtyards, providing a further connection to nature. Operable louvers are used in place of glazing to allow for passive ventilation. The butterfly roof design allows rainwater to be collected and filtered through rain gardens, which is then stored in nearby cisterns. The manufacturing facility is split into 4 separate labs, divided by green bands. The mechanical spaces in the warehouses are on the ground floor, while the main lab spaces are raised onto a second floor. Initial planning was informed by research into each of the 4 lab types: painkillers, biologics, antibiotics, and IV fluids. Split into 4 bands, they are all connected by an entry corridor, then follow product-specific flows leading to a warehouse. Incoming goods are brought from the warehouse to the beginning of each lab flow via elevators. Goods then follow the production process, and once finished, they are sent to the warehouse via elevators located at the end of each flow. One main corridor connects labs together and leads to quality support and lounge areas. Exterior bridges accessed via the corridor pass through green bands and lead to an occupiable green roof above the warehouse. Ramps are provided on either side for public access. Labs raised above the warehouse provide views out towards the natural landscape for workers, and the created green roof can be occupied by workers during lunch breaks or by members of the community who wish to view science on display. Each green band is an important aspect of the design and serves multiple functions. In addition to exterior circulation, these bands allow natural daylighting into lab spaces and provide views out towards nature. The roof slope leads rainwater to irrigation trenches for filtration and storage, while excess water is fed into adjacent rain gardens. Louvers and bamboo poles are incorporated as shading devices against the bright sun. Lab spaces need to be controlled and clean environments, so the internal structure surrounding them is composed of a concrete core, while exterior walls are more lightweight and constructed using metal studs and glazing. Reinforced cast-in-place concrete is used as the foundation for the main floor slab, as this needs to support heavy loads and equipment. Internal concrete bearing walls meet concrete beams. These, in addition to steel wide flange beams, support the roof structure. The building is meant to appear as though it is hovering, and so buttresses support the cantilevered slab, which extends to meet the steel bridges within the green band. The design proposal for this bioprocessing facility aims to create a park-like setting within the Kamuzu University Teaching Hospital, promoting human well-being by forming natural connections in a new and innovative facility for all users.